What's our point? Now here's the thing, we could do this for a lot of numbers, right? But the point is that some will be bounded, some will be unbounded. Now, this we started with I, right? Now where is that? Where is that? On this plane, it's going to be up, right? These are where my imaginary numbers go, right? So I would be up here, okay? Now just for the sake of interest, have a think about a number like this, minus 1 plus I, right? Where would that be? Well, here's the real part, negative 1. And here's the, yeah, it's kind of like a coordinate system, which is why I've got my axes, right? Negative 1 plus I will be over here, okay? All right, now, rather than make you do a whole bunch of these, I'm going to show you the shape that you get if you color in all of the bounded values. It looks like this. This is gonna be hard, okay?
Oh. What is
Oh wow.
Hold on. This is really hard to draw, okay?
It's a clown. No. It's a rock. Wait, no. No, it's the devil's marbles.
What I've got here, and if I colored this in, like all of this is filled, okay? What you've got is a set of numbers. It's a set of numbers. For instance, here are some of the numbers: 0, an eighth, negative 1, negative a half. Some of the numbers like I, negative 1 plus I would be in here as well. Right? So what you've got here is a graphic representation of a set of numbers. This whole family of numbers, it has a name. It's called the Mandelbrot set. Okay? Named after a guy named Benoit Mandelbrot. Okay, yeah. Now, as you can see why I struggled to draw it. Okay? Hold on. Rewind. We started this lesson, we walked in and we said, what topic are we under? We're under the topic of fractals, right? And then I started doing all this weirdo algebra business. Can you see what's going on now? Okay? In fact, those of you who spent any time on like my website or my channel know I'm kind of in love with this shape. This is my favorite shape in all of maths, okay? And it's a fractal, right? It's unfortunately very hard to draw freehand, okay? But what's really interesting about it, and is you can kind of see here, but I'm going to zoom in further and show you more, right? Can you see the scale symmetry? Can you see it, right? It's everywhere, right? In fact, let's go in a bit further. Let's zoom in on a point like here, okay? And you can see that a bit better, right? And you can see all of the same shapes, right? Like so. And they go on forever. You know, you'd expect it to kind of like become boring after a while. For instance, if you think about x squared, y equals x squared, okay? When you zoom out, it's pretty interesting. It's like, oh, this cool, oh, sorry, I missed. This cool sort of parabolic shape, right? But as you zoom in, right, you start getting this shape which is sort of flats out. And as you zoom in really, really far, you just get like, it looks like that. It's so flat across the bottom, right? But you zoom into this thing, and it never flattens out. It never becomes simple. You just get more and more of the same kind of shape. It's crazy, okay? Just like you would expect it with these guys, right? Right? If we were able to draw this forever, we could zoom in forever, and we could see this kind of scale symmetry going on, you know, off into infinity, okay?